Welcome to week 3 with Mrs. Bibb. I hope that you are having a positive experience so far at our school. We're glad you're here. We want you to learn. We want you to do well. And we want to prepare you for what may be in your future. Okay, as we look at this week's lesson, we're going to solve absolute value equations. Make sure to fill in your table of contents. Do your warm-up for the week, Monday through Friday. Check that warm-up. And we're going to need Student Journal 19, 20, and 21. So, if you'll make sure that you have those pages, we will begin. Okay, an absolute value equation is an equation that contains absolute value and remember, when you see absolute value equations, you actually have to solve two equations. There are two answers normally to an absolute value equation. An extraneous solution is just a solution that does not satisfy the equation. Extraneous, that's a fancy word. But it's just an equation that does not satisfy the solution. Now let's talk about, it doesn't have me define it, but let's talk about absolute value. What is the definition of absolute value? The distance a number is from 0. That's what absolute value is. What if I told you I had a number that was 5 units from 0? And you don't have to write any of this, unless you didn't know what the definition of absolute value is, and you may want to write that. So what if I told you I have a number that's 5 units from 0? Is my number positive 5? Or is it negative 5? I'd have to tell you if I was asking for a number that's 5 units from 0. Something else that I want to point out, how far is it between negative 5 and 5? What's the distance? The distance is 10 units. And 0 is in the middle of those 10 units. That's something you'll need to remember for some problems we'll do later on, some application problems. Here's some properties about absolute value. This is just saying when you take the absolute value, your number is bigger than 0. If you want to write out a translation, you're welcome to do that. You do need to be able to gain the skill of looking at math writing and knowing what that means in your own language or terms. So this means the absolute value of a number is always bigger than or equal to 0. What's this mean? If you have a number and you take the opposite of it, when you take the absolute value, they're still the same number, negative 3 and 3. The absolute value of negative 3 is 3. The absolute value of 3 is 3. 3 is equal to 3. Same thing here. There's not a difference when you multiply two numbers and take the absolute value than if you would take the absolute value and multiply. It would be the same thing. And then this one says if you divide two numbers, b can't be 0 because you can't divide by 0. That's why it gives that stipulation. But if you divide two numbers, you're going to get the same value if you take the absolute value. Okay. We're going to get into solving absolute value equations. Here's the form that they give you. If you have this absolute value equation, then you rewrite two linear equations, ax plus b equals c, or ax plus b equals negative c. Remember, do not change the sign of what's inside of the absolute value. Here's how I think about it. I can take the absolute value of a positive number and get a positive. And I can take that positive number that I took the absolute value of and make it negative, and take the absolute value of a negative number and get that same number. So we have to remember that the value inside of the absolute value, and I want to show you something really quickly. Do not put absolute value here when you're solving your equations. Do not do that, because it's not proper to have this. So when you write your two equations, they are two equations that are linear, not absolute value. How do you know this is an absolute value equation? Because it has absolute value symbols around it. So remember, do not put absolute value around your two linear equations. Remember, linear means that the largest exponent is 1. Okay, so my two equations, I take this, keep it positive, and I take this and make it negative, because I can take the absolute value of a positive number and get a positive, and I can take the absolute value of a negative number that's like that and get a negative number. So that's, rewind that. I can take the absolute value of a positive number c and get c, and I can take the absolute value of a negative number c and still get c. So write two linear equations. Now, notice this. I want to point this out. See if you can translate it. I'll read it and think about it as I highlight. When c is less than 0, the absolute value equation, absolute value of ax plus b equals c, has no solution, because absolute value always indicates a number that is not negative. So let's have a translation of that. What does that mean? That means that whatever value I have in place of c, c must be positive. If it's not, then the answer is no solution. So remember, c must be positive. Then the last thing, we'll do these problems last, but I'll go ahead and talk about it. If you have absolute value on each side, then what you do is pick a side, and I normally pick this side that I'm going to make the opposite. You keep this the same and set it equal to what's inside of this absolute value. Or you keep this the same, set it equal to the opposite of what's inside of here. So technically, you could say, because I'm going to distribute, that I would take the opposite of both terms or all terms inside the absolute value, negative cx minus d. So that's what you do when you have two absolute values. You take the opposite of one of the sides, and I always choose the right side to take the opposite of. Okay, let's dive into some examples. Let's look at number 1. Now, number 1 is kind of tricky. The absolute value of something equals 0. Is 0 positive or negative? Neither. So that means that I'm only going to have one solution, because this is what we would normally write. Okay, I have absolute value. I'm going to write my two linear equations. I'm going to take what's inside the absolute value, set it equal to this c value, or, and that's just the conjunction you use, take what's inside of the absolute value and set it equal to the opposite of that c value. Well, does that make sense to write that? No. So this would be the one exception where you only have one solution to this problem when it equals 0. So I'm going to solve by subtracting 12. 3x will equal negative 12. Divide by 3, x would equal negative 4. So that's my solution. And then how do I graph one solution? This is not like the summer work where we're going to have shading. We're going to graph one solution, and that's how you graph it. X equals -4. Let's look at question 2. It's different because my C value is 8. So I am going to have my two equations. I'm going to write my two linear equations that will not contain absolute value. Take what's inside the absolute value, y plus 2, set it equal to 8. Use your conjunction or. Take what's inside the absolute value. Let me point out again, never change the sign of what's inside the absolute value. Only change the sign of C. And what's the opposite of 8? -8. Solve both of your equations. I'm going to sneak down here and write my final solution. So y is going to equal to 6, or y is going to be equal to -10. -8 minus 2 is -10. So there's my two solutions. I'm going to show you something else in just a moment. And 6 is a solution, and -10 is a solution. Oftentimes on a standardized test, you will see these solutions written this way. Honestly, this is the best way for me, but if you decide to use this, that's okay too. But this is the best way to write your solution to an absolute value problem, or any that give you two solutions. Okay, let's look at number 3, still on page Student Journal 21. I have a -4. What do we do with that? Many students will say to distribute. This is my rule of thumb. The reason why it's my rule of thumb is because sometimes it's okay to distribute into absolute value, and sometimes it's not. So in the world of sometimes, I don't like sometimes. I like rules that are straightforward. This is what you do. I never distribute into my absolute value ever. So I'm going to divide both sides by -4. I'm going to have the absolute value of 7 minus 6k equals -14/4. But 14/4 will reduce. They're both divisible by 2. So -7/2. Now let's pause for just a moment. When I look back at the problems I had, C was +8. That gave me two solutions. C was 0, so it's neither positive or negative, and that gave me one solution. But now I have C to be a negative. Can you take the absolute value of a number and can you take the absolute value of a number and get a negative answer? No. So this one, you stop. You do not continue, and you say no solution. No matter what value you pick for k, you're not going to find a solution that will equal a -7/2. Let's look at the next one. Is this negative? No, so we're good. We can write our two linear problems. I have d divided by 3 equals 3, or d divided by 3 equals -3. Take what's inside the absolute value, set it equal to the number on the right. Use your conjunction or. Take what's inside the absolute value, set it equal to the opposite of the number on the right. Then multiply both sides by 3. You will get d equals +9. Multiply both sides by 3. D equals -9. So my two solutions for number 4 are -9 and +9. And then to graph those, a solid dot on -9, solid dot on +9.